Telepresence robots are equipped with audiovisual systems for real-time two-way communication. As these robots become more common, it is important to ensure that sharing sensitive data remains private and secure, especially in public settings. This work studied 6 methods for sharing sensitive information via telepresence robots. These methods are pen and paper, where users write down sensitive information on paper and then present it to the telepresence robot operator. Robot display, in which users enter information directly on the robot's touch-sensitive screen using a virtual keyboard or keypad. Smartphone, by which users type information on a smartphone and then hold the device up to the camera. Speech, where users share information by speaking naturally, without modifying their tone or volume. Whisper, where users share sensitive information by leaning toward the microphone and speaking softly. Silent speech, during which users communicate sensitive information by mouthing words without producing sound. We first conducted an online survey where participants watched short videos of the methods and rated each on effort, comfort, privacy, usability, convenience, and social acceptance. Initially, the survey collected 252 responses, but after excluding unreliable entries, 79 responses were considered for the final analysis. Results revealed that the robot display and smartphone methods were perceived as the most effortless and convenient, with pen and paper following closely behind. The smartphone method was rated as the most private and secure, with the robot display and pen and paper close behind. In contrast, speech-based methods were considered significantly more socially acceptable than other methods from both performers' and observers' perspectives. These findings contradicted our expectation that pen and paper and smartphone methods would be seen as inconvenient and cumbersome due to multiple steps and the need for additional tools. We were also surprised that speech-based methods rated highly on social acceptability, despite previous studies indicating discomfort with speech in public settings. Hence, to investigate whether this preference was influenced by participants not using the methods firsthand, we conducted a follow-up Wizard of Oz study. In the study, 12 participants used the methods to share fictitious sensitive information via an only telepresence robot and rated them using the same questionnaire as in the survey. Quantitative data was also collected. Results showed no significant differences in preparation and verification times between methods, likely because participants were provided with all necessary tools to eliminate confounding variables. However, input time varied significantly, with speech being the fastest, followed by pen and paper, smartphone, and robot display. Unlike the survey, user feedback indicated that the speech method was perceived as the easiest and most convenient, while the pen and paper method required the most effort and was the least comfortable. The robot display method was rated highest for privacy and security, followed by the smartphone and silent speech. The robot display method was considered significantly more socially acceptable from both performers' and observers' perspectives. The speech-based methods were deemed the least socially acceptable, although silent speech performed relatively well among them. These shifts in participants' perceptions after using the methods highlight the importance of hands-on testing for novel technologies. Based on the findings, we recommend offering multiple information sharing methods in telepresence robots to enhance both usability and privacy.